morning and dzień dobry at DevOps. I hope you hadn't such a hard time to actually find that room. It was pretty hard for me, at least. My name is Mark Paluch. I'm working with Pivotal on the Spring team. And today I'm going to talk about how to scale security with an approach that is even feasible for things that are run on a smaller scale. So why is this important? So most of us, when dealing with remote services, use passwords to authenticate on services. And while authenticating is good, you have to store somewhere these credentials, usually username, password, tokens, all these kind of things. And where do you put these things? Well, you put that to the system environment, you store that in config files, and mostly in a similar form like we have it here on the screen, unencrypted. So everybody who has access to that configuration is able to read that security credentials. And you have basically no control over that, what's going to happen. Because once it's exposed to the environment or to a file, everybody who has access to it, well, reads it, and you do not know who has access to that, who has read that, and who is actually authorized to use those credentials and who's not. So that's not cool. You can do certain things about that, like encryption, by simply encrypting that piece of information which is sensitive and you do not want to disclose that. That's an example from Tommy, which uses static DES encryption to encrypt the password. So this is nice because at the first sight you do not really see what's in there. But if you take a deeper look and look up the key, you are then again able to decrypt that. That's one important ones for the authorized user of this credential. But if you are not authorized, you are still able to get access to that. Well, you can do other things about that. Instead of packaging the encryption key with your software together, you can store the key somewhere outside of your system. So you have one piece of information which is encrypted, and then you need to access the key. And if you put it in some place where it's more or less secured, the application is able to access it, and you are able to rotate that key without necessarily redeploying your application. That's good, because you have done encryption, and if you have picked a strong cipher, that's even better. But then you have, again, a sort of chicken and egg problem. Because, well, now you have encrypted your data, and you have an encryption key, but what about security on the encryption and decryption key? Everybody who has access to the sensitive data and access to the decryption key is able to decrypt the data. So while you have introduced encryption, you have also introduced another problem about securing the key. And securing the key is even more worse than plain text passwords, because everybody who has access to the encryption and decryption key is able to decrypt data which was encrypted with that particular key. So again, not so cool. But there are things you can do about that. Well, you can say, okay, well, I can put that key in a hard-to-guess location, and once the application has started up, it accesses that key and deletes that key. So you remove that key on application startup, and after the application has started up and decrypted all the credentials, the key is gone, and you reduced the risk that somebody else is able to access the key. However, there is a possibility that an attacker could scrap the key before you delete it, but you reduce the amount of time where this is actually possible, and you reduce the possibility after application startup that the key is still present. That works, but this comes with another constraint. Well, what about application restart? So imagine your application crashes and then wants to restart up, and the key is gone, so your application is no longer able to, well, start up again. So you have to operate manually, and you have to place the key again in that place, start up the application, which comes with an ops overhead. So again, some constraints which aren't cool, and even if you have a microservice architecture with lots of instances, lots of services running, that isn't necessarily something you want to do for all the 1,000 instances you are running. If you take another look, what else is possible is, what about crypto modules? Hardware tokens that you plug into your machine, and then all sensitive information is stored on these things. That's possible, like this USB key, but has anybody tried to plug in such a USB key in your AWS instance? Well, unlikely. Data sensors are protected, and even if you are not on Amazon running or Google Cloud, it's hard to get access to the data center actually, and you do not want to deal with these kind of things when you are running at scale, because you are just busy sticking in these USB things into your computers. So not cool either. And then when you maybe went for the easy, simple approach to encrypt all the data, and you find out, okay, well, our passwords got compromised, or we do rotate passwords and keys, you have to do that for every single instance and make sure that you redistribute all the keys, all the passwords, which isn't fun either. So in the long run, encryption and handling of secrets like we do that today isn't fun. But there is an approach, and there is a tool to do so, and this tool is called Vault. And Vault is basically a tool for managing secrets. So what are secrets? Well, secrets are things you do not want to disclose, and you do not want to sprawl them across your whole runtime environment. And the secret can be a password, a token, a credit card number, a social security number, basically everything you want to protect from everybody else who's not authorized to see it. Vault is made by HashiCorp, and HashiCorp is the company who made tools like Consul, Vagrant, Terraform, Nomad. So that's mostly a DevOps company, and they saw the need to do something about secrets. And Vault itself is a service. It's a network service which exposes you an API, and you can use that API from your application, from your provisioning systems, and what have you, to securely access secrets stored inside of Vault and retrieve these secrets with authentication, with audit logging, and all that stuff that really matters when you treat security seriously. So what Vault basically does for you is it encrypts secrets. It uses AES 256 in GCM mode. That's the strongest cipher available right now. And encrypts data at rest. So everything you put into Vault is encrypted for you and stored securely. It allows you a notion of sealing and unsealing. So imagine if you get compromised. Today, with credentials inside of files, you have no possibility to lock out people. With Vault, you have the possibility to shut down the whole service, and if you get compromised, you simply stop Vault, and nobody is able to access the data stored inside of Vault. Vault supports multiple authentication mechanisms, authentication workflows for manual, for people authentication, and compute machine authentication. And it stores multiple, it has support for multiple secret backends. So secret backends are basically these things where you store or retrieve secrets from. It works with ACLs, so access control lists, and policies, where you can assign a policy to a specific user. So the user is able to access only that part he's authorized to and not more. It's able to run in high availability mode to basically prevent you from having a single point of failure. And it exposes a really nice HTTP API. And how this looks like, well, I'm going to show you in a second. But before, there are two editions of Vault. There's a community edition, which is very powerful. It comes with a lot of useful features. The features I mentioned, it has audit logging, it has access control lists, it's able to cluster. So a lot of really cool features. And then you are able to pay for Enterprise Edition. And with Enterprise Edition, you get enterprisey features like 24/7 support for hardware security modules, like the secure modules on Amazon, other modules that you can plug into your data center. You get replication, managed instances. But since we are talking today on a community edition, let's forget about enterprise right now. So let's take a look how to use and initialize Vault. And Vault itself is a binary. I've downloaded it. It's a similar binary like, well, when you know console, then you may be familiar with that concept. It's a binary that contains the client and the server aspects. Can you read that? Yeah. And to start Vault, I need basically two things. I have a configuration file that specifies some details, like I'm storing the data in memory. I don't want to have that persistent. I could store that basically on the file system, in Amazon's DynamoDB, MySQL, these kind of things. Specifying the listener address and optionally other things like to not use swap, because when you are using swap, then things might leak to disk again, and since Vault stores its keys in memory, that's something you do not want to have. So you see, Vault is built pretty much with security in mind all over the place. And now let's get back to the server. It's Vault server -config vault.conf. And by this one-liner, I'm able to start the Vault server. And by default, if I start Vault for the very first time, it's empty. And it's empty from the data side, and it's empty from the encryption side. Well, since Vault requires a key to encrypt the data, we have to provide one or generate one. And this process is called initialization. It wouldn't be such a great idea if every single Vault instance would use the single key across the globe. That would be unfortunate. So on the very first startup, you have to initialize Vault. That's my Vault server running here. I have to provide a Vault address. Let's store that in the environment. And now with Vault in it, I'm going to initialize Vault. And before I do that, let's discuss maybe how Vault stores the secrets, the secret master key. So usually you do not want to have one single person to be in control of the master key of everything, because that might be a security concern. You usually want to distribute that responsibility, and Vault copes with that by splitting the master key in a number of chunks. This algorithm used to split that chunks is called Shamir secret sharing algorithm. And if you wonder who's Shamir, that's the S in RSA. And let's initialize Vault and tell it with key shares. Oops. Key shares is 5, and key threshold is 2. And what I'm basically specifying here is split the master key in 5 parts, and I require 2 arbitrary parts, to unseal Vault. And Vault is showing me right now these keys. And that's the only time I'm able to see these keys. After that, if I lose that keys, I'm no longer able to access Vault. So that's a critical part in your setup, because you have to make sure that you do not lose these keys. And the other part is, well, I'm currently here as a sort of ops, and I'm able to see these keys. So I've broken the rule I mentioned earlier, that no single person should be able to control Vault entirely. And with this, there's a measure to that, which allows you to specify PGP keys, where we are here. So if I specify PGP keys, every single Vault key share is encrypted with that PGP key, and only the owner of the private key of the PGP key is able to decrypt that. And by that, you get a out-of-the-box secure system. So let's get back to unsealing. To unseal Vault, I'm running Vault un. Yes? Exactly. So if I generate 5 keys, I can specify up to 5 PGP keys, and every share is encrypted with the according PGP key. So let's unseal that with the first key. Then I need the second key. So I see specifying this help thing wasn't unfortunate. Vault unseal the second one. And now from the output, you see on the first attempt, Vault was sealed. In the second attempt, finally unsealed Vault. So now Vault is able to operate. And I provided the master key to Vault by that. So the master key is only one part of the thing. And now, as a user, I need to authenticate. And Vault uses tokens for these kind of things. And on initialization, Vault generates one single root token, so that's the master thing. And by using this token, I then can set up additional authentication and create other tokens. Let's authenticate against Vault with this token. Whoop. Export Vault token is this one. And for Vault status, I should be able to access Vault. Okay, finally. So let's write stuff into Vault, like Vault write to the secret backend, and say DevOps, year is 2017, and I successfully wrote data to Vault. With the Vault read command, I can then again read data out of Vault, and so that's a very basic interaction. And behind the scenes, Vault using an HTTP API, which allows me to access and read all the data which is stored inside of Vault. Let's take a look on what else we are able to do. Well, I'm using an HTTP client here, and doing a direct access into Vault to see how that feels. Secret DevOps, specify the Vault token, and since I did that on the environment variable, I have to pass it into the client as well. Vault token, and then I'm able to access Vault. And as you see, that's a very simple JSON response that you're getting. Here's the payload I specified, and it comes with additional metadata that allow me to do other things within Vault, but we will get to that in a minute. So the important bit on using Vault is that you have to specify a token on every request. And how you get that token, it depends a little bit on your workflow and your requirements. Right now, I used the root token generated by the initialization, but you can allow your users and applications to get tokens with other means, because in fact, storing a static token somewhere in a file is not really better than storing plain text passwords. Well, in fact, a little bit it is, but still everybody who has access to that token is able to pretend to be the application or the authorized user, and that's nothing you want to deal with. So let's take a deeper look on what secret backends means. Well, we have that generic secret backend that does encryption and decryption with AES 256 for you on the fly. That was the secret backend. But Vault has also integrations into other systems like RabbitMQ, Console, AWS. It has a PKI backend, database backends. And what this basically means is that you are able to generate credentials for these services using Vault. So for the PKI use case, it might be that you are able to generate client certificates on the fly without bothering your own certificate authority, but rather use Vault as an intermediate certificate authority. For MySQL, this might mean you are able to generate usernames and passwords which are managed by Vault, so you do not need to bother your ops people to generate a credential for you and revoke that credential accordingly. And let's take a look on the console how this works. So Vault itself has this notion of mountable backends, and I'm able to mount the MySQL backend into Vault. By default, it mounts to the MySQL SQL path. I have a MySQL instance running on my machine, and once I've mounted this backend, I have to tell the backend where to connect to and which roles to apply. And I'm doing this with the console command line client, right? MySQL, no, that's not that right. That's the right thing. So I'm telling basically Vault to use my local host with a master username and password to connect to MySQL. And in a second step, I'm specifying the role I want to use. So I'm creating a read-only role. So that's a line break, so not a great read. I'm creating a read-only role and specifying the SQL to be used to create that user. So basically saying here, okay, create user, take the name variable and the password variable, and then grant read-only rights, so grant select on, to that particular user every time Vault is creating this kind of user. So these are the two basic ops steps I need to do to make Vault ready for MySQL credential generation. And after that, I'm able to read credentials from Vault by saying Vault read MySQL creds read only. And with this, I get a couple of information of which the username and the password are the most interesting one. So let's take a look on what MySQL does. MySQL rejects me without username and password. And if I specify username and password, let's take this one, and then the password, I'm able to use MySQL, and I've received a token which is generated and managed by Vault. And what does this mean? Well, Vault has a notion of leases. So maybe you have noticed this lease duration up here, which is about 32 days. So what this means is that Vault is going to revoke that particular credential after the lease time has expired. And how is this good? Well, in today's applications, you request once a username and password for your database, and after that, it's basically eternal until the server dies or until you get compromised, because nobody else is going to change that credential. And that's an issue, because the longer a credential is valid, the higher the possibility that it gets exposed and that somebody is accessing it without being actually authorized to that. And to deal with that issue, Vault introduces the notion of leases, and once the lease is expired, I can revoke that particular credential. And if I see that I get compromised, I have this lease ID, which is a pointer to the credentials generated, and that's some arbitrary UUID. And I can revoke that if I notice that my application gets compromised. So let's get back to MySQL and revoke that. Revoke and give it that particular ID. And when I then try again logging in, I get an access denied from MySQL because Vault has revoked that particular secret from my MySQL server. And this works with every single integration for MongoDB, Cassandra, Postgres, Microsoft SQL Server, SAP HANA, and Oracle are right now in the works. So there are plenty of possible integrations, and Vault has opened up their API for custom plugins. So if you have some data store which isn't supported by Vault, then simply write a little bit of Go code, and then you are able to use that custom plugin with your custom solution by reusing Vault and that powerful capabilities. So another thing which might come to our mind is, well, I was talking about tokens and user and machine authentication. And using static tokens is a possibility, but it's not the best possibility because tokens can leak. And so you have to do something with Vault in order to obtain a token for you or for your application. And since machine and people authentication are very different, Vault allows you to authenticate with different means. It has a user and password store built in. You can connect it to your company LDAP. If you are using GitHub, you can use GitHub and Teams to control that access. And on the other hand, for machine authentication, you can authenticate with TLS certificates and other authentication mechanisms, of which April and AWS EC2 are the most interesting ones, because on AWS you are able to authenticate with actually nothing really setting up inside of your application. And how this works? Well, I'm going to show you. AWS EC2 instances are able to retrieve instance metadata. So you do an HTTP request to a metadata service, and it returns you information about your instance you are running. And there's even a signed metadata copy available that you can fetch. And this signature is this trust thing, which is used by Vault. So Vault uses AWS as trusted third party to make sure that it provides you the right information, and to verify the signature that the document you've provided is authentic and it wasn't tampered by anybody. So as an application, you retrieve that metadata, you post that to Vault, and Vault then goes to the AWS API, checks whether the instance is running, whether you're authorized to do so, and after that, it gives you a token back. So there's one caveat to that authentication mechanism, because everybody who has access to that EC2 machine via SSH, via some means getting into your application, is able to retrieve that identity document as well and post that to Vault. And and Vault secures that by providing a nonce. So it's the principle trust on first use. So the very first user that tries to authenticate against Vault has to supply a random nonce, store that somewhere, ideally in memory, and reuse that nonce on every subsequent request to retrieve a token. And if somebody else comes with another nonce, he's simply rejected from Vault. And by that, you make sure that only the very first user is able to access Vault and to retrieve that token. By using the audit log, you're even able to detect compromise if your system got compromised, because the audit log records every single action that was performed with Vault. And based on the audit log, you can set up alerting, and so you get notified if something happens which you didn't actually want. Another very interesting authentication mechanism is based on the Vault primitives itself it provides to you. So not only secrets, but also tokens have the possibility to expire, and tokens are able to be assigned to a usage counter. So you can create a token where you set the usage limit to 1, and once this token is used once, it's invalidated, and subsequent usages of this token will create an unauthorized exception. And with a special secret backend called Cubbyhole, you can combine these factors to create yourself an own authentication mechanism, which is called the Cubbyhole Authentication. So you can tell Vault, hey Vault, please create me a token and store this token in a Cubbyhole backend. And what Vault is going to do is it's creating a token, storing it securely, and giving you back again a token which allows you to access that token stored inside of Vault. So Vault isn't revealing the actual secret to you, but rather a pointer, so you can then, as an application, access to that. So why is this good? Well, it is good because you do not see the actual secret, and this so-called wrapper token has a usage counter of 1, and once this token is used by anybody, it's invalidated. So subsequent requests are rejected, and you can use that to find out whether anybody else has used that token once, or you are the first one who uses this token to reveal the underlying information. And when you do that inside of your application accesses Vault with this ephemeral token, retrieves the data stored in Cubbyhole. The usage counter is decremented. The token you've used initially is also invalidated. And then you can use the data stored inside of Vault, which is the permanent token, to use that as a permanent access token during your application runtime. And then you're again in possession of a valid token, which is valid through the application runtime. And you can use it, and if your application fails to start because of timeout or because Vault rejected you because anybody else has used the token, you get a notion of, okay, I got compromised, I have to investigate why this happened. And this again helps you to keep the security bar up high. So some operation hills which came to our mind after we used Vault for quite a while is, well, the whole secret and encryption story makes only sense if you use an encrypted transport, and Vault defaults to SSL and especially to TLS 1.2 by default. And it restricts clients as well to use that high number of the protocol version. You can allow Vault to use a smaller protocol version, but this comes then with some trade-offs on the other hand. So use SSL only, otherwise encryption and transport doesn't really make sense. You need to keep the unsealed keys in a secret place, and storing that plaintext on a USB token or writing it on a post-it isn't secret. You should keep it either PGP encrypted or in a very secure place for yourself. And you should run Vault in a high availability mode to prevent that when one node goes down, that every other application isn't able to access secrets. So run it HA, otherwise you won't really have fun. And from the Spring side, we have as well some integrations for Vault, which is Spring Vault, that's for purely Spring applications, and Spring Cloud Vault, which is based on Spring Boot and as a configuration integration. So what do I need to do to integrate my Spring application with Vault? Well, I'm starting a new application on start.spring.io using the web dependency, using the Vault configuration dependency. So that's already pre-configured for you. And let's take the actuator as well to get some insights on the property structure. And as soon as I'm generating the project, I'm getting the zip file here. And let's open that project in my IDE. So now I have an empty project without anything inside it. What I need to do first is, because Vault is a configuration solution which runs in a bootstrap context, I have to rename the application properties to bootstrap properties. And Vault is a URI-oriented addressing thing, so I'm dealing with context names, and I have to specify somehow what I want to access within Vault. And we are using the Spring application name for this case. Let's set that to my Spring Boot app. And the second thing is I need to authenticate against Vault. And to do so, I'm simply using a static token for now. Don't do this in production. For demos, it's cool, but don't do this when you are really going to production. And then, finally, I'm accessing properties. Let's say my key, inject that into some variable, which is my key again, and print it out. So post-construct is a nice way to do so. So that's one thing. And basically now my application is ready to access Vault secrets. And I need to prepare my Vault setup because the first one I did isn't suitable for that. But I have some demos for it. I will show you the links to that after the presentation. And now my application is able to access Vault and to run with Vault. Let's see what happens right now. And maybe you have seen it. Whoop, here we go. He has written my value to Vault. And let's write something else into it. Let's use this window. Vault, write, secret, my Spring Boot app, my key is hello DevWorks PL. Restart the application, and then we will see the change value in here. Hello DevWorks PL. Here we go. So that's one thing. And the other thing is you can, this Spring Vault integration creates so-called property sources. And with the actuator, we can actually see what's stored inside of these property sources. So that's a possibility to inspect the data. Localhost 8080/env. Oh no, I'm not authorized. I did something wrong. Oh, obviously. So let's restart the application and take again a look. Here we go. So here with this environments endpoint, I'm able to see what's retrieved from Vault, and by default, Vault requests a constant path which matches the application name and the default name named the application. And I can adjust that as well by activating profiles. So if I'm going to production or having a cloud profile, so that's what I activated right now, I can specify that, and Spring Vault will pick up these for me. So you see my Spring Boot app /cloud, and here we have some stuff which is simply showed and pulled into my application. So it's very simple to integrate Vault inside your application. And another thing which is pretty cool about Vault, but that was added recently, is TOTP. So anybody has heard of TOTP? Anybody? Okay. So TOTP is a security mean that if you are using like Google or Apple accounts and you enable two-factor authentication, TOTP is this little barcode you scan, and it allows you to generate a token to authenticate with your application. And how this basically works is you're generating a TOTP key. Let's call this foo. This generates you such a barcode, and I can now take my phone and Touch ID. Oh, I hate you. Take my phone, take Google Authenticator, scan that. So let's do this. No. Let's do it this way. Okay, and then I'm receiving a 6-digit number. And why does this matter? Well, the security token I'm getting here is again something which is sensitive. And when you're doing two-factor authentication within your application, you need to store that as well securely. And Vault has a TOTP backend, and I have here a number which is 081774. I can verify that. You see, it's working. Let's do the negative test. Do something different, and then I'm getting an error again. So Vault provides you with a lot of interesting backends. And as a final backend and integration, I want to show you the MySQL integration. And the MySQL integration is located in the examples project on GitHub. So we have a complete example project with a lot of modules that show how to use Vault as a Hello World thing or how to integrate with MySQL. And what I basically need to do for the MySQL integration is I need to enable that backend. So that's these 2 lines, specify where my data source is. And I'm not required to provide any usernames and passwords here, because that's something that is Vault doing for me. And by enabling the MySQL backend, I get username and password generation out of the box, and I then can simply continue using my data source within my application. And what this piece of code is basically doing is it's connecting to MySQL, getting the current user, and then shutting down the application. Let's give it a try. And you see, here we go. There's a username created by Vault. And the nice thing here is, as soon as your application shuts down, the Vault client expires all the secrets created by Vault. So this account is no longer valid after my application has shut down, which is actually a nice thing because you generate a one-time account for your application. You start it up, generate it, use it, and once your application shuts down, these credentials are no longer valid. So I think I will wrap up my talk. You can download, you can get all the resources, all the code from GitHub. That's an open source project which works. So Spring Cloud is an open source project which works with Spring Cloud and Spring Boot. And we have a smaller version which is only Spring Vault. And you are not required to use the Spring context at all within your application, but you are able to benefit from the client components which are built in there and use it with almost every Java application you have out there. There are samples for the various integrations. There are samples if you run on Cloud Foundry. There's as well a connector for that allows you with zero configuration in your application to access Vault. And that's what you get on these URLs. So I hope you enjoyed my talk. I will be around on DevOps here for quite a while. And if you have questions, feel free to come here. I've brought some stickers with me. And enjoy DevOps. Dziękuję.